Good morning friends. Welcome to Parnika's Tutorials YouTube channel. In the last video, I have discussed how to insert elements in the AVL tree. I hope you have watched that video. For your better understanding, in this video, again I have taken some elements. With these elements, I want to create an AVL tree. I request everyone to watch the complete video for better understanding. What are the elements I have taken? 45, 70, 37, 4, 71, 28, 80 and 60. These elements I want to insert in the AVL tree, and with these elements I want to create the AVL tree. So the first element is 45, which will act as a root node. Now the balancing factor of this one is 0. So in the AVL tree, the balancing factor should be in the range from -1, 0 or 1. If it is so, I can say that it is an AVL tree, otherwise I will say that it is not an AVL tree. Next I want to insert 70. 70 is greater than 45, so I will insert here because first it should satisfy the properties of the binary search tree. What is the property of binary search tree? The elements which are there in the left subtree should be less than the root node, and the elements which are there in the right subtree should be greater than the root node. Now compute the balancing factor. Balancing factor of this node is 0 and balancing factor of this one is -1. How to compute the balancing factor? Height of the left subtree minus height of the right subtree. Height of the left subtree is 0, height of the right subtree is 1. So 0 minus 1, you got -1. Still, all the elements, the balancing factor is in the between range from -1 to 0. So I can say that still it is an AVL tree. Now you want to insert 37. Now 37 is less than 45, so you will insert here. Now compute the balancing factor of each node. This is 0, and this one will be height of the left subtree is 1, height of the right subtree is 1, 1 minus 1 is 0. So all the elements in this tree are having the balancing factor 0, which is in this range, so I can say that it is an AVL tree. Okay, now next you want to insert 4. 4 is less than 45, less than 37, so you will insert here. Now you compute the balancing factor of each node. Okay, now this one is 0, this one is 1. Why? Height of the left subtree is 1, right subtree is 0, 1 minus 0 is 1. This one is height of the left subtree is 2, height of the right subtree is 1, so 2 minus 1 is 1, and this one will be 0. So still all the elements balancing factor is in the range from 0 to 1, so I can say that it is an AVL tree. Now next I want to insert 71. 71 is greater than 45, greater than 70, so I need to insert here. Now compute the balancing factor. The balancing factors of these two nodes will not vary. Whose nodes will be vary? This one, and this one will be there. Now balancing factor of this one is 0. Balancing factor of this node is -1. Balancing factor of this node is 0. If you have a doubt, you can check it. Balancing factor of this one, how I got 0? Left subtree minus right subtree height is 0. This one is height of the left subtree is 0. Height of the right subtree is 1. So you got -1. And this one, height of the left subtree is 2, height of the right subtree is 2, so 2 minus 2 is 0. Now still it is in the range of -1, 0 and 1, so I can say that still it is an AVL tree. Next you want to insert 28. Where you need to insert 28? 28 is less than 45 and less than 37, greater than 4. So 28 you need to insert here. Now once you inserted the 28, these two balancing factor will not change and the remaining values balancing factor will change. Now how it will change we will discuss now. The balancing factor of this one is 0, this one is -1 and this one is 2, because height of the left subtree is 2 and height of the right subtree is 0. Now this is not in the AVL tree range because it is -1, either 0 or 1. Now if you want to compute the balancing factor of this one is 3 minus 2 is 1. So this one is not in the AVL tree. Now you take that part 37, 4 and 28. Now you can look at this one. Because of which node this balancing factor is out of the range or improper balance? It is because of this 28. You have inserted 28, that's why this value balancing factor has become 2. So from this node, go to the newly inserted node. First you need to go towards the left side, because from 37 you need to go to 4. From 4 you need to go 28. Now you need to go to the right side. So you need to do the LR rotation. Is it clear? You need to do the LR rotation. LR rotation is nothing but first you need to perform RR rotation. After RR rotation, you need to perform the LL rotation. So take this part 4, 28 and then you take the dummy element here. First you need to perform RR rotation on this one. If you perform RR rotation, you hold this one and this 4 you need to rotate towards the left side. If you rotate it, you will get 28 here, 4 here and dummy. And this 37 you need to add. Now what rotation you need to perform? LL rotation. So the need for this dummy element is completed. So you can erase this one and then you need to perform LL rotation. How you will perform LL rotation? You will hold this 28 and this 37 you need to rotate towards the right side. If you rotate it, it will come here. So it will be 28, 4, 37. So you will erase this one. After performing the LR rotation, you got it as 28, 4, 37. Now you compute the balancing factor. This is 0, this is 0, this is 0 and this is also 0 because 2 minus 2 is 0. Now all the nodes balancing factor is in the range of 0 and minus 1. It is still AVL tree now. Previously it was not AVL tree, now it is AVL tree. Okay. Now you have to insert 80 because you have inserted 28. Let me erase this one. Now you need to insert 80. Now where you need to insert 80? 80 is greater than 45, greater than 70, greater than 71. So you need to insert 80 here. Now compute the balancing factor of each node. This one will not vary. This part will vary. Okay. Now how it will be, we will check it. Balancing factor of this one is 0. This one is minus 1. This is minus 2. And this one will be 2 minus 3, which is minus 1. I hope by this time you know how to compute the balancing factor of each node. How it is minus 2? Height of the left subtree is 0. Height of the right subtree is 2. So 0 minus 2 is minus 2. Now this element balancing factor is out of range. So take this element. Which node you have inserted 80? Go towards that one, which is nothing but you need to go towards the right side. From here again you need to go to the right side. So you need to perform RR rotation. So take that 70, 71, 80. You need to perform RR rotation. How you will perform RR rotation? You will hold this middle element and this 70 you will rotate towards the left side. So if you rotate it, you will get 70 here, 80 here, because if you move this one towards the left side, it will come and it will be attached here. So you need to erase this one. After performing the RR rotation, you got 71, 70 and 80. Is it clear? Now you compute the balancing factor of each node. This is 0, this is 0, this is 0 and this one will be 0 because height of the left subtree is 2, height of the right subtree is 2, so 2 minus 2 is 0. So after inserting 18, we got the RR rotation and then after performing it, we got the AVL tree. Now I need to insert 60. Where I need to insert 60? 45 is the root node, 60 is greater than that one and less than 71. So you need to go here and less than 70. So 60 will come here. Is it clear? Are you able to understand? Because 60 is greater than 45, I came to the right side. 60 is less than 71, so I will go towards the left side. And 70 is there. 60 is less than 70, so you need to insert here. Now after inserting, we need to compute the balancing factor of each node. Anyway, this will not vary, these nodes, these three nodes, but again, anyway, I will discuss for you so that it will be practice for you. What is the balancing factor of this node? 0. This is 1 and this one will be 0. This is 2 minus 1 is 1 and this one will be 0, this one will be 0, this one will be 0 and this is 2 minus 3 which is minus 1. Now if you look at all the elements balancing factor is in the range of minus 1, 0, 1. There is no 2 minus 2, so I can say that this is an AVL tree. So I hope you have understood how I have constructed the AVL tree from these elements. So with these two examples, I hope you have understood how to construct the AVL tree. Still, if you have any doubts, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Just for practice, I request everyone to create the binary search, AVL tree with these elements. 1, 2, 5, some 6 you can take, and you can take 4, you take 3, and then you take 8. With these elements, you construct the AVL tree, and then you tell me how many LL rotations you have performed, LR rotations you have performed, RL rotation, and RR rotations. How many you have performed, you please write it in the comment section. Is it clear? If you are not able to do it, then I will clear your doubt. Thank you for watching the complete video. Have a nice day.